So friends, this is our fourth question to solve or to form a partial differential equation, which states show that the differential equation of all cones which have their vertex at the origin is px plus qy equals to z. Okay, and this particular question was asked in 1979 and then repeated in 2009 in IS exams. So, sorry, to solve any such question, first thing is that you should know the equation of a cone who have vertex at origin. And the equation is ax square plus by square plus cz square plus 2hxy plus 2gxz plus 2fyz equals to 0. Okay. Now, as usual, whenever we need to find a partial differential equation, we differentiate with respect to x and with respect to y, and then let us see what we have. Okay. So differentiated it with respect to x, we have 2x plus when we differentiate y with respect to x, we have 0. So 0 plus when we differentiate cz square we get as 2cz dou z by dou x plus here we get 2hy plus 2gx into dou z by dou x plus here we have differentiated with respect to x to z. Now we'll differentiate to x treating z as constant. Okay, so we will get it as 2gz plus here 2fy into dou z by dou x equals to 0. Now wherever we have dou z by dou x, we'll replace it with p. Okay, for our simplicity. And another thing is that we see this 2 everywhere. Okay, so let us take it common, put it to right side, and it's eliminated. So rewriting it again, we have ax plus hy plus gz plus now from here we have p p. Taking p as common, it can be written as p into cz plus gz plus fy. Okay, cz. Okay, here we have gx, cz plus gx plus fy equals to 0. This is our equation 2. Okay, similarly now when we differentiate with respect to y, what shall we get? We will get as 2by plus 2cz into dou z by dou y plus 2f y into dou z by dou y plus 2fz plus 2gx into dou z by dou y. 2gx plus 2h equals to 0. Okay. Now again, we'll replace this, and this with q. Okay. And remove this 2 from here because it's everywhere. Hence, we will get as by plus fz plus hx plus q into cz plus fz plus gx equals to 0. Clear till here? Again, I have made a mistake here. Yeah. cz fy gx. We had a y here, right? So fy. So gx equals to 0. Let us say this is our equation 3. Now What we can do is that multiply equation 2 with x, okay, multiply equation 3 with y, and add these two. So what shall we get? We will get as ax square plus mm, hxy plus gxz plus p into czx plus gx square plus fyx, okay, plus by square plus fzy plus hxy plus q into cyz plus we have here fy square plus gxy. Okay, this is equal to 0 now. We have multiplied second with x, third with y, and added these two. So what do we get here on adding? Mm, see, we have xy here, yz here, xz here. So at least we can add xy terms. So rewriting it again, we get it as ax square. Let me use another color. This implies ax square plus by square plus 2hxy plus gxz plus fzy plus mm, now mm, mm, mm. Here if I take, see, this particular term, there is x common, so I can write it as px into cz plus gx plus fy, okay, and in this particular term there is y common, so I can write it as plus qy into cz plus gx plus fy, okay. So here this term and this term, these two are common, equals to 0. So I can rewrite it as ax square plus by square plus 2hxy plus gxz plus fzy plus, if I take cz plus gx plus fy common from last two terms, I will get as cz plus gx plus fy into px plus qy equals to 0. Okay, let us say this is our equation 4th. Now, we have reached till here. Now, somehow we have to eliminate these arbitrary constants, which are a, b, c, g, and all. What we can do is that, okay, see, here we have ax square plus by square plus 2hxy, okay, gx and fzy. And in the original equation of cone, we had ax square, by square, okay, 2hxy. Here we had one gxz. Yes, we have two gxz. There we have only one gxz. Here we have two fyz. There we have one fyz. So we can replace this particular thing. One sec. If I rewrite, let me write first the given equation of cone that we had written earlier, ax square plus py square plus cz square plus 2hxy plus 2fyz plus 2g, what we have taken as 2gxz. Okay, now see this particular equation, can I write it as ax square plus py square plus 2hxy plus gxz plus fyz equals to minus of cz square minus of gxz minus of fyz. Okay, so now this particular thing I can replace with this thing here. Okay, so let us see what we get. This implies minus cz square minus gxz minus fyz. Here it is plus cz plus gx plus fy into px plus qy equals to 0. Now, from these terms, can I take z as common? Or let us say minus z as common. I'll get as minus z into cz plus gx plus fy plus this term as it is cz plus gx plus fy into px plus qy equals to 0. Now, if you observe this and this is same, so we can take it as common. So we are left with cz plus gx plus fy into px plus qy minus z equals to 0. Now, if this particular term has to be 0, then this has to be 0 or this has to be 0. Okay, so but we need a partial differential equation. We take as px plus qy minus z equal to 0. This is the required partial differential equation. Okay, and this is what we were asked to prove. See, the question was to prove px plus qy equal to z. Okay, and we have got like px plus qy minus z equal to 0, which can be written as px plus qy equals to z, taking z on the RHS. Okay, thank you.